Watch this video about the central limit theorem. You use the central limit theorem when working with groups. The first question states scores for women on the verbal portion of the SAT test are normally distributed with a mean of 502 and a standard deviation of 109. Randomly selected women are given the Columbia Review course before taking the SAT test. Assume that the course has no effect. The first question asks, if one of the women students is randomly selected, find the probability that her score is at least 535. This is a basic normal distribution problem. We have to find the probability that x is greater than or equal to 535. First, convert 535 to a z-score using the z-score formula. The formula states z equals 535 minus 502 divided by 109. This gives us a z-score of 0.30. We're going to find the probability that z is greater than or equal to 0.30. The probability is 0.6179 when the z-score is 0.3. Now, since it's a greater than problem, we have to subtract 1 minus 0.6179, and the final answer is 0.3821. The next question asks, if 25 of the women are randomly selected, find the probability that their mean score is at least 535. Since you're dealing with the group, we have to use the central limit theorem. We first convert 535 to a z-score. To do this, we use our formula. The z-score equals 535 minus 502 divided by 109 divided by the square root of 25. The z-score is 1.51. So we're going to find the probability that our z-score is greater than or equal to 1.51. The area is 0.9345 when the z-score is 1.51. Again, since it's a greater than problem, we have to subtract 1 minus 0.9345 to get an answer of 0.0655. The third part of the question asks, if finding the probability for part B, why can the central limit theorem be used even though the sample size does not exceed 30? The central limit theorem can be used because the original population is normally distributed. The fourth part of the question states, if the random sample of 25 women does result in a mean score of 535, is there strong evidence to support the claim that the course is actually effective? Why or why not? Since the probability 0.0655 is greater than 0.05, the probability is not small. We can assume the claim is correct. The claim is the course has no effect. Question 2 states the lengths of pregnancies are normally distributed with a mean of 268 and a standard deviation of 15 days. Part 1 asks, if one pregnant woman is randomly selected, find the probability that her length of pregnancy is less than 260 days. We're finding the probability that x is less than 260. First, convert 260 to a z-score. We have z equals 260 minus 268 divided by 15. The z-score equals negative 0.53. We're asked then to find the probability that z is less than negative 0.53. The probability is 0.2981 with the z-score of negative 0.53. That is the answer. The next part of the question states that if 25 randomly selected women are put on a special diet just before they become pregnant, find the probability that their lengths of pregnancy have a mean less than 260 days. The claim is that we're assuming that the diet has no effect. Here we use the central limit theorem because we're working with a group. First, convert 260 to a z-score. Our z-score equals 260 minus 268 divided by 15 divided by the square root of 25. The z-score equals negative 2.67. So we're finding the probability that our z-score is less than negative 2.67. The probability is 0.0038 when the z-score is negative 2.67. Part C, if the 25 women do have a mean of less than 260 days, should the medical supervisors be concerned? 0.0038 is a small probability. It is less than 0.05. It appears the special diet decreases the length of pregnancy and likely the development of the fetus. The last question states women's weights are normally distributed with a mean of 143 pounds and a standard deviation of 29 pounds. An elevator in the Atlanta Women's Club is limited to 16 women, but it will be overloaded if the 16 women have a mean weight in excess of 157.5 pounds, yielding a total weight in excess of 16 times 157.5, which equals 2,520 pounds. If 16 women occupy the elevator, find the probability that their mean weight will exceed 157.5 pounds, causing the elevator to be overloaded. If the elevator is occupied by 16 women 12 times each day, how many times is it likely to be overloaded in a year? Is that number low enough to be of no concern? To answer the first part of the question, we're finding the probability that x is greater than 157.5. First, using the central limit theorem, convert to a z-score. Our z-score equals 157.5 minus 143 divided by 29 divided by the square root of 16. The z-score is 2. So we're trying to find the probability that our z-score is greater than 2. A z-score of 2 gives an area or a probability of 0.9972. Now subtract 1 minus 0.9972. The probability is 0.0028. To answer the next question, how many times is the elevator likely to be overloaded in a year? Well, 12 times a day, the elevator is overloaded. There are 365 days in a year. So if we multiply, we have 4,380 times a year that the elevator is overloaded. The probability that that happens is 0.0228. So if we multiply the amount of times times the probability, that equals 100. So approximately 100 times a year the elevator is overloaded. The last part of the question, is that number low enough to be of no concern? No. The elevator being overloaded at all could result in injury or death.